Anytime we run into an electrical hazard, it can be very life-threatening to our responders. With all the other things we're worried about, with fire and traffic and everything else, electricity is just another one of those things that we have to deal with. It's important for us to determine where and how to shut off the electricity. Crawling around, our boots have an electrical hazard rating on them, but they're not tested. In fact, if they've had a hole in them, and every firefighter's had a pair of boots that's had a hole in them, they're no good anymore for that. And we aren't walking on our feet. In most cases in a house fire, we're crawling. So we're crawling in wet gear in a wet environment, and you can crawl right across to an outlet or a cord that's laying on the ground that's energized, and then find yourself in a lot of trouble. The problem with electricity is it's silent. It's a silent killer. You don't know it's there unless you've confirmed that it's not. It's always considered to be there. Everything is considered energized. Everything on a pole, any wire coming down off the pole could be energized if it's in contact with another wire. So in a house, unless you've been told and confirmed that it's de-energized, consider everything energized in that house.
The usable voltage of the consumer, that 120 volt, is more than sufficient to kill you. It's 50 volts to push a quarter of an amp through the human body, and that's enough to kill you.
People always think about how many volts are there, and it's really not the voltage that hurts you, it's the current that hurts you. And it takes less than 1 amp to kill you. A standard outlet in a house, a normal breaker for a standard outlet would be 15 amps minimum. It could be up to 20 amps. So there's plenty of current available in a standard outlet to kill you. So we want to avoid any contact with electricity whatsoever. Everybody wants to get in and get going. Fire can grow very rapidly. So taking the time to secure the utilities can be a challenge for some departments because it takes another person to do that. And then if you get there and you can't shut things off outside, it's very tempting to try and do other things, and you really have to wait for the utility at that point. And that can be a very difficult thing to do with emergency responders. You can never train enough for an occupation that you can die in. So even as a volunteer, the risk is still there. A fire is a fire. It doesn't care whether you're being paid to be there or whether you volunteered to be there. So it's important for both volunteers and career fire departments to focus on this thing. And it doesn't happen very often. That's the thing. It isn't a huge risk factor because we don't see it happen so much, but when it does, it's a tragedy. So we want to make sure we're prepared for that, realizing that the electricity is in every house. It's going to be in every incident that we respond to, at least as in a structure. So we need to make sure that we have a plan to mitigate that.
Education on how to deal with a power line situation, a utility situation will greatly decrease the likelihood of a fatality to a first responder due to the situation.
In your firefighter training, you should have been trained to properly disconnect utilities, including water, gas, and electricity. Electricity should always be done with a switch or a disconnect point. Never do the meter. The meter is not a switch, it is not a disconnect point. Don't take your cutters, go up on a pole and try to cut wires loose either. Wait for the utilities to do so. In disconnecting the utilities, certainly wear your full PPE. It's not intentionally designed for arc flash protection, although it is NFPA rated for fire and heat protection as well. So it will offer quite a bit of protection. Make sure your face shield's down and wear safety glasses if you can. Certainly you could wear your SCBA and do that disconnect as well. Call the power company first. When you're heading to a structure fire and you know you're going to be needing to do a disconnect, call the utility, get them on the way. They don't have the luxury of driving with lights and siren, so it takes a little longer for them to get there. It can be very frustrating waiting for them, but they do not have the luxury of emergency response that we do. It takes less than 1/10 of an amp to put somebody into cardiac arrest. Your household current itself is rated at 15 amps on a normal breaker, so we're well over the limit that we need. You don't want to mess with it. If you're outside and you've shut off a main disconnect and their automatic standby generator is downstream of that main disconnect, it will automatically turn back on and re-energize the house. Smart homes, it is designed to keep itself alive. It's designed to keep itself energized. So when you shut the power off, even if the utility shuts the power off to it, it can turn itself back on. So you need to make sure that you're aware of where those are. Most of them will either run on gasoline or propane or some type of natural gas. So there usually is a place to disconnect by that generator as well. We've got UPSs for computers that can potentially backfeed if wired improperly. We're putting battery packs inside of homes now. That is inside the garage. It's inside the facility. Can create some fire hazards for us. But again, the power can come back on and you didn't expect it to. Installed properly, there should be a sign that says there is an alternate energy source there. Examples would be a generator, solar panels, battery backups, things like that, if it was done properly. The odds of it being done properly on small standby generators that you can buy at local box stores are very limited. I've said this before, the meter is not a switch, it is not a disconnect point. Pulling that meter, if that meter it isn't capable of breaking the load at that point, that meter could blow up in your face. It could actually cause more problems and more damage. Beyond that, though, not all the meters have all the current flow going through them. Some of them, there is an actual instrument somewhere else that is sensing the current flow and it sends it to that meter. So the act of removing that meter does absolutely nothing to disconnect the service at all. And if you don't know that, if you aren't trained to that, you shouldn't be doing that either. The act of opening that meter up, on the backside of some of these instruments, you can have incredibly high voltage generated, which could actually injure people that are exposed to them. So it's just not good policy to pull the meter ever. So wait for the utility to properly disconnect. A common call that we get is a car versus pole. And a lot of times, the power line isn't down, but you don't know that until you get up on the scene. So as you approach that scene, you want to make sure that you're looking at all of the hazards that are on that scene, other vehicles, traffic, everything else that's there, including the power line. Once that pole is damaged, we can have all sorts of potential for wires to fall, or there could already be wires down on the vehicle. And again, they don't make any noise. If they're not sparking, you may not visibly see, but the vehicle could still be energized. So the first thing you want to do is make sure that you secure the scene, keep anybody from the public from approaching that vehicle, and include your crew. Your crew shouldn't approach that vehicle as well. If you can stay in your vehicle, you're much safer staying in your vehicle. And if you make contact with the power line because you didn't see it, back up and just try to get away from it with your vehicle itself. If there is people in the vehicle and the vehicle is energized, we want them to stay there. We don't want anybody to touch that vehicle at all. Now, that's going to be very difficult. If that person is unconscious, you're going to want to go help them, but you've got to stay back. You've got to make sure that you don't become a victim. If the vehicle is on fire, well, that creates another challenge for us. We want to try and control that fire as best we can. The best way to control that fire is to have the utility shut off. Any electrical fire, if you can just shut the power off first. If the victim is capable and has to exit that vehicle, then we would want them to try and jump free of the vehicle, not touch the vehicle and the ground at the same time. You think about if you drop a rock in the water, how it sends those ripples out from there. Electricity is doing very similar to that. When the electricity energizes the car, you have a ripple effect in the earth. We call it step potential or touch potential. Touch potential is if you're touching the car and the ground at the same time, you could become shocked.